Welcome to Breaking News to Trading Moves. Imagine a future where a car company is valued, well, not by the horsepower of its engine, but by the processing power of its microchips.
Yeah, that is a wild concept to wrap your head around, but it is exactly where we are heading.
Right. Today, we are looking at a specific headline that provides a concrete timeline for exactly that scenario. And we are examining the resulting winners and losers from this very targeted piece of news.
Exactly. We want to see where the capital is moving.
So here's the headline we are focused on today. Samsung Electronics founder chief announced at a shareholder meeting that they expect to begin volume production of Tesla chips at Samsung's factory in Texas in the second half of 2027.
Yeah, and setting expectations right away is just critical when dealing with a manufacturing timeline like this. I mean, the second half of 2027, that is a long-term target.
Right, it is pretty far out there.
It really is. We have to clarify for you that this is not a 2026 revenue catalyst, nor is it, a delivery catalyst for the near term. We are looking at a long-term signal regarding custom hardware.
Yeah, so not an immediate financial event for the current fiscal year.
Exactly. The market looks at an announcement like this to understand where capital is moving over a multi-year horizon.
And we want to be very clear with you, the listener, that we are not exaggerating the immediate impact here. We aren't saying this changes the whole world tomorrow.
No, definitely not.
But the way the market interprets this long-term signal, well, it tells us exactly who benefits from this narrative. So to understand the immediate trading takeaways, we need to transition directly to the company named in the headline and its closest peers.
Right. And to grasp the main beneficiary, you really have to look at how Tesla has positioned itself over the last decade.
Yeah, they've taken a totally different path.
They really have. They have spent a massive amount of time and capital trying to stand out through software, artificial intelligence, and hardware integration.
So this announcement is just validating that path.
Precisely. This production announcement out of Samsung shows that Tesla wants even tighter control over the compute layer of their vehicles.
The compute layer. Let's explore that idea of the compute layer for a second, because the mechanics here dictate exactly why certain stocks win or lose today.
Yeah, it is the core of the whole thesis.
Right. Because a traditional vehicle architecture is, well, it's incredibly decentralized. You have dozens, sometimes hundreds, of tiny, separate computers called electronic control units, or ECUs.
Oh yeah, they are everywhere in a normal car.
Exactly. I mean, if you roll down a window, that is one chip. If you hit the brakes, that is another chip. Adjust the air conditioning, and that is yet another chip.
And they all have to communicate over this massive, heavy wiring harness that runs all through the chassis.
Right. And that traditional method, it creates latency, it adds physical weight to the car, and, it makes over-the-air software updates incredibly difficult.
Yeah, because you were trying to get 50 different generic chips from 50 different suppliers to talk to each other seamlessly. It is a nightmare to update.
But Tesla's approach, which this headline validates, is the exact opposite. They are centralizing that processing power into a singular, powerful brain.
Exactly. It is a completely closed-loop ecosystem.
It is essentially what Apple did with the smartphone, right? They designed their own proprietary operating system, and they designed the specific silicon that runs it.
That is a perfect way to look at it.
So let me ask you this. If an automaker controls the hardware processing their software, does that give them a long-term edge in vehicle performance compared to companies buying off-the-shelf parts?
Oh, absolutely. When an automaker designs the chip that runs their specific code, the efficiency gains are just massive.
Because it is totally optimized for their system.
Exactly. A custom system on chip, or SO, integrates functions to reduce latency and power draw. And, in an electric vehicle, saving power directly translates to longer battery range.
Right. They aren't waiting for a third-party chip designer to update a generic processor that has to work for 10 different car brands.
Exactly. So when a company gets validation around a long-term compute strategy like this, investors notice. The market starts to re-rate the broader idea that the next phase of the auto industry is being won by software-led electric vehicle companies.
Rather than the traditional manufacturers.
Spot on.
Well, this brings us to the clear winners of this specific headline. Obviously, Tesla, trading under TSLA, is the direct beneficiary.
Right, because it is literally their chips being manufactured. It validates their long-term custom silicon narrative.
But there is also a sympathetic winner here, and that is Rivian, trading under RIVN.
Yeah, Rivian is a great call-out.
Because Rivian has adopted a very similar philosophy with what they call a zonal architecture. They are drastically reducing the number of individual computers in their vehicles, too.
Right. And investors favor software-centric EV platforms over older auto models. So an announcement that champions vehicle compute ends up shining a really favorable light on Rivian as well.
Because the market processes this type of information by rewarding the broader philosophy. The spotlight hits the company pushing the boundaries, and the glow catches the companies operating with similar architectures.
Exactly. But, to make this centralized architecture work to actually control that compute layer, you require incredibly advanced chips.
You can't just use standard parts.
No, not at all. So a focus on custom silicon naturally directs investor attention to the wider automotive semiconductor ecosystem that makes all of these advanced systems possible.
Okay, this brings us perfectly to the hardware backbone. If vehicles are effectively becoming computers on wheels, are chip designers essentially the engine builders of the new auto industry?
They absolutely are. Automotive compute remains a strategic growth market, and the designers of those new engines are just perfectly positioned to win.
Because the market recognizes that if vehicles require increasingly more processing power, the entire automotive AI stack gains attention.
Right. This is no longer just about horsepower or battery range. It is entirely about processing power and data management.
Let's define exactly how this ecosystem works, because there's a crucial difference between designing a chip and actually building one.
Oh, massive difference.
Yeah, companies like NVIDIA, trading under NVDA, and AMD, trading under AMD, operate on what is called a fabless model.
Right, meaning they don't actually own the factories.
Exactly. They are the premier architects of advanced computing. They draw the incredibly complex blueprints for the chips, but they do not own the massive factories required to physically manufacture them.
But they still benefit from this broader AI chip narrative because they provide the core technological designs that the auto industry increasingly relies upon.
Right. And alongside NVIDIA and AMD, we have to talk about a company like Mobileye, trading under MBLY.
Yeah, Mobileye is a really compelling part of this story. They benefit because this news refocuses the market on the distinct value of driver assistance and autonomy silicon.
Because self-driving is so compute heavy.
Exactly. When the market sees custom silicon moving into volume production for self-driving goals, it reminds everyone that the entire category of automotive AI requires specialized, high-performance hardware.
And Mobileye provides complete hardware and software packages specifically for autonomous driving.
Which makes them a clear sympathetic winner when the narrative focuses on advanced vehicle compute.
Okay, so we have the fabulous chip designers winning. But the physical chips, well, they have to be made somewhere. NVIDIA and AMD draw the blueprints, but someone has to actually build the house.
Right, and that physical construction happens at a semiconductor fabrication plant, commonly known as a fab.
And the headline specifically mentions Samsung's factory in Texas.
Which is a huge detail. Ramping up complex production in America benefits the domestic equipment ecosystem immensely.
Because building these fabs is no small feat.
It is unbelievable. Building a leading-edge fab is one of the most capital-intensive projects on Earth. We're talking about facilities that cost tens of billions of dollars to construct.
Wow.
Yeah. They require clean rooms that are exponentially cleaner than hospital operating theaters, and they rely on highly specialized machinery to print microscopic circuits onto silicon wafers.
So the companies that make the machines that make the chips are landing squarely in the winner's column today. They're essentially selling the shovels during this gold rush.
That is exactly what they are doing. You are looking at companies like Applied Materials, trading under AMAT, Lam Research, trading under LRCX, and KLA, trading under KLAC.
These are the heavy hitters of the equipment providers.
They really are. Lam Research, for example, focuses heavily on etching microscopic patterns into the silicon.
And KLA focuses on metrology and inspection,
Right.
ensuring there are no microscopic defects on the wafers.
Exactly. And Applied Materials provides a very broad range of materials engineering solutions.
So even though they are not the direct subject of the Samsung and Tesla news, they are the crucial backbone of the ecosystem.
Without them, none of this happens. When a facility in Texas ramps up to volume production, it requires billions of dollars worth of this specific machinery.
So these equipment names benefit from any sign that leading edge or specialty semiconductor capacity is growing in the U.S.
Absolutely. We see clearly where the capital and attention flow toward advanced computing.
Which means now we must look at where that attention is drawn away from.
Right, because a headline like this revives the ongoing comparison between heavily integrated compute-focused EVs and, well, traditional auto models.
This is where the trading pressure points emerge. Let's look at how Ford, General Motors, and Stellantis are trying to survive in a market where they historically do not own the brain of their own cars.
Yeah, that is a tough position to be in.
Are these legacy automakers essentially buying off-the-rack suits while Tesla is tailoring its own? And I want to clarify for the listener, these older companies aren't weak at their core, right? They are just exposed in the current market narrative.
Yeah, that is exactly it. Ford, trading under F, General Motors, trading under GM, and Stellantis, trading under STLA, are not structurally broken businesses.
Not at all.
They have massive scale, they sell millions of vehicles globally, and they possess immense physical manufacturing expertise.
But on a trading basis, they look less differentiated right now.
Precisely, because they rely much more heavily on third-party suppliers for their software and chip needs.
And the market is currently valuing proprietary compute very highly.
Very highly. Investors are asking a very pointed question right now. Which automakers really control their future software and chip stack, and which are still relying on a patchwork of external vendors?
And because they lean heavily on that off-the-rack approach, Ford, GM, and Stellantis find themselves on the losing side of this specific trading narrative.
They simply look less vertically integrated than their pure-play EV competitors. If you do not own the underlying technology that runs the car's primary systems, well, you are at the mercy of the companies that do.
And that reality brings trading pressure directly to the traditional auto suppliers themselves.
It really does.
Let's examine those traditional suppliers. We are talking about companies like BorgWarner trading under BWA, Lear trading under LEA, and Visteon trading under VC.
Suppliers tied to conventional vehicle architectures face near-term pressure today.
Because the industry is moving away from their core products.
Exactly. If the market firmly believes that next-generation vehicles will be defined by proprietary compute and centralized electronics, these traditional suppliers just get less investor attention.
Take a company like Visteon as an example. They traditionally manufacture dashboard displays and conventional electronics.
Right. And if an automaker puts all of the vehicle's processing power onto one centralized brain, the older, distributed electronic components made by traditional suppliers become increasingly obsolete.
The auto value chain strongly favors high-value compute and AI-enabled hardware over conventional components.
Now, to be fair, the traditional parts these companies make are still necessary for millions of cars on the road today.
Sure, they aren't going to zero overnight.
Exactly. But the premium valuation, the excitement, and the capital flow is moving toward the companies enabling advanced software and hardware integration.
So it is not just the legacy automakers losing mind share to the EV pioneers. The traditional parts suppliers are losing mind share to the advanced silicon designers.
That is exactly the dynamic playing out. And there is one more layer to this, which is the battle for advanced manufacturing contracts.
Right, because that creates a clear dividing line between competing global foundries.
It does. Samsung securing Tesla's future chip production at their Texas facility acts as a stark reminder of who is successfully supporting these high-profile programs.
And the race for strategic chip manufacturing wins is highly competitive on a global scale.
Oh, incredibly competitive. In the foundry business, proving your manufacturing process is viable at scale is incredibly difficult. You are trying to convince the world's top technology companies to trust you with their most advanced, mission-critical designs.
And we have major U.S.-listed foundries trying to prove exactly that. So does Samsung winning this business effectively take the wind out of the sails for domestic competitors trying to prove they can win these exact types of advanced manufacturing relationships?
It absolutely creates a major narrative challenge for them. You have to look at Intel, trading under INTC, and Global Foundries, trading under GFS.
Both are major U.S.-listed semiconductor manufacturing stories.
Right. And Intel in particular has been very vocal about its strategy to become a premier foundry for other companies, not just manufacturing its own internal designs.
So when investors see Samsung successfully landing a marquee client like Tesla, right in Texas, they immediately compare that positioning and deal flow against Intel and Global Foundries.
Exactly. The pressure on Intel and Global Foundries today is not necessarily about their technology failing on a technical level. It is really about the optics of losing a major contract in their own backyard.
The pressure here is purely narrative.
Completely narrative. Winning high-profile clients proves your capabilities to the broader market. This headline reinforces that Samsung is winning that advanced manufacturing mindshare right now.
Which leaves Intel and Global Foundries looking like laggards in the current market conversation.
Right, they have to work a lot harder now to prove they can secure similar high-volume advanced compute contracts.
Okay, let's bring all of this together for you. The primary trading takeaways from this announcement are clear. The cleanest direct winner is Tesla, TSLA, as the news directly validates their long-term custom chip strategy.
And we also see those secondary wins for the automotive AI and chip ecosystem, specifically the fabless designers NVIDIA, NVDA, and AMD, along with Mobileye, MBLY.
Plus, the equipment manufacturers providing the literal machinery for these fabs also win, including Applied Materials, AMAT, Lam Research, LRCX, and KLAC.
But on the other side, the trading pressure lands on legacy autos like Ford, General Motors, GM, and Stellantis, STLA.
And that pressure also extends to the legacy supply chain, relying on conventional vehicle architectures, including BorgWarner, BWA, Lear, LEA, and Visteon VC.
Finally, those U.S.-listed foundries, Intel, INTC, and Global Foundries GFS, take a narrative hit as Samsung claims a major victory in the advanced manufacturing space.
So what should we be watching for moving forward?
Well, you should watch for a few specific details. The market will be looking for clarity on the exact architecture and nanometer process of the chips Samsung will actually produce for Tesla.
We also need to monitor adherence to that 2027 timeline, right?
Oh, absolutely. Manufacturing advanced silicon is incredibly complex, and timelines can frequently slip. Finally, watch for any future expansion in Tesla's AI or driver assistance roadmap that might explain why they need this specific volume of custom chips.
Because until those technical details emerge, the market will naturally fill in the blanks with its own assumptions regarding capital expenditures and production capacity.
They always do.
Consider a future where a car company's computing power and silicon strategy matter more to its overall valuation than how many physical vehicles roll off its assembly line. That reality is approaching faster than many realize. This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.